afternoon, sir. Good afternoon, classmate. Today, I will discuss the verifying the method. First, my objective. At the end of the lesson, you will be able to understand what is verifying method, identify the process in verifying method. Introduction. Verifying the method is essential in creating a real-level result. It refers to the process of confirming that a specific analytical method performs reliably and accurately within a particular laboratory setting. This process ensures that the method produces a valid result when applied to a real sample. After developing and optimizing a method, the next step is to determine how well it works in the hands of a single analyte. There are four steps to make up this process. So first, determining single operator characteristics. Second, completing a blind analysis of standards and determining the methods of ruggedness. And last is equivalency testing. If another standard method is available, then we can analyze the same sample using both the standard method and the new method and compare the result. If the result for any single test is unacceptable, then the method is not a suitable standards method. Verifying method. Verifying method is the process or refers to the process of confirming that a specific analytical method performs reliably and accurately within a particular laboratory setting. This process ensures that the method consistent a valid result when applied to real sample. Accuracy and detection limit. When a single analyst uses the method to analyze a standard sample, the detection limit is determined by analyzing an appropriate reagent blank. Precision is determined by analyzing replicate portion of the sample, preferably more than 10. Accuracy is evaluated using a t-test to compare the experimental result to the known amount of analyte in the standard. Precision and accuracy are evaluated for several different concentrations of analyte, including at least one concentration near the detection limit. And for each different sample metrics, including different concentration of analyte, helps to identify constants, sources of determined error, and to establish the range of concentration for which the method is applicable. So next is blind analysis of standard samples. Single operator characteristics are determined by analyzing a standard sample that has a concentration of analyte known to the analyst. The second step in verifying a method is blind analysis of standard samples. Although the concentration of the analyte in the standard is known to a supervisor, the information is withheld from the analyst. After analyzing the standard sample several times, the analyte's average concentration is reported to the test supervisor. To be accepted, the experimental mean must be within 3 standard deviations as determined from the single operator characteristics of the analyst's known concentration. So, yung pangatlo is ruggedness testing. Optimizing may produce excellent results in a laboratory that develops a method, but poor results in other laboratories. This is not particularly surprising because a method typically is optimized by a single analyst using the same reagent, equipment, and instrumentation for each trial. A variability introduced by different analysts, reagent, equipment, and instrumentation is not included in a single operator characteristic. Other less obvious factors may affect an analysis, including environmental factors such as the temperature or relative humidity in the laboratory. If the procedure does not require control of this condition, then they may contribute to variability. Finally, the analyst who optimize the method usually takes particular care to perform the analysis in exactly the same way during every trial, which may minimize the run-to-run variability. Important step in developing a standard method is to determine which factors have a pronounced effect on the quality of the results. Once we identify these factors, we can write a specific instruction that specifies how these factors must be controlled. A procedure that, when carefully followed, produces results of high quality in different laboratories is considered rugged. The method by which the critical factors are discovered is called ruggedness testing. Last is equivalency testing. If an approved standard method is available, then the new method should be evaluated by comparing results to those obtained with the standard method. Normally, this comparison is made at a minimum of 3 concentration of analyte to evaluate the new method over a wide dynamic range. High slope of 1.00 and intercept of 0.0 provide evidence that the two methods are equivalent. That's all for my report. Thank you.